All right, hi Science 10s. Welcome to your next lesson. You're starting a new workbook now. It's dynamics and energy. We'll get started with dynamics and what we refer to as forces. All right, so what's a force? Well, before we get into that, okay, dynamics is the study of forces on matter. What's a force then, right? As a push or a pull. It describes why things move. So objects can be pushed, okay, or pulled with given forces, and those forces can result in movement of that object. So it can change the velocity and the direction of the object. Okay, so all changes in motion in this universe, as far as we know, are caused by forces. Okay. Now, if an object doesn't change its state of motion, whether it's in a constant speed, or, well, say this again, a constant speed or velocity, or at rest, which is also a constant speed or velocity of 0, then we say the object is in equilibrium. All right, we'll get to this in the next slide. Forces are vectors, they have directions, therefore they have magnitudes as well. All right, so now coming back to this business of equilibrium, this is Newton's first law of motion. What does it state? An object tends to maintain its motion unless acted upon by an unbalanced force. So an object in motion tends to stay in motion. Okay, this object is in motion and it will stay in motion unless an unbalanced force, meaning a force that acts upon it, which is different from the forces that were acting upon it originally. Okay, if an unbalanced force acts upon it, less, for example, an unbalanced force pushing this object, it will change its direction and its acceleration and therefore its speed. Or an object at rest tends to stay at rest unless acted upon by another unbalanced force. So objects at rest will have the force of gravity pulling down on them to the surface. The surface will push up, and that will be the balanced force, and the object will maintain its at restness. All right? But if any force is pushed on the object, then it will change its direction and its speed. Okay, so maintaining motion, as we've been talking about, means having a constant speed and direction. Unbalanced forces means that the net force is not 0. Okay, net force in this case with gravity pulling down and the surface pushing back up would be equal. So if gravity pulled down with 10 newtons, the surface that the object was sitting on would also push back with 10 newtons. That means it's a balanced force. 10 and 10, right, equals 0. Okay, so 10 pushing down, 10 pushing up equals 0. Okay, so we call this the law of inertia. Okay, and inertia is the resistance to change in the motion of the object. So another example here, all right, we have two pails that are being hung on a string. Okay, now this pail has no sand in it, the other pail has sand. The pail with sand will therefore be harder to push because it has more mass, therefore it will have more inertia. So the greater an object's mass, the greater its resistance to change by unbalanced forces. Which brings us to Newton's second law of motion, all right, where the acceleration of an object is directly proportional to the magnitude of the net force, so how big the net force is, and is in the same direction as the net force. Now, in Science 10, we're really not going to be dealing with net forces, just one force on an object. So net forces you can deal with later. So if you're having trouble understanding this unbalanced forces, don't worry about it because we're only going to deal with one force on an object anyway. So all of our forces in Science 10 will be unbalanced. So Let's look at these two diagrams. The force is big, therefore the object will accelerate at a greater rate. So here's your acceleration line, which is bigger. Here's the object, okay, which is bigger than this one. The object is the same mass, the force is smaller, the acceleration is smaller. So what does this look like as far as its formula? It's an object, m, that is accelerating must have a force acting on it. So F equals ma, where force is in newtons, which is a kilogram meter per second squared. Just use newtons. A is acceleration in meters per second squared. M is mass in kilograms, base units, kilograms, meters, seconds. Let's start a problem. Oh, before we do that, we just need to make sure that we understand the relationship between F and M and A. All right, so in this silly example, we have a golfer, he's putting a golf ball and he's putting a truck. Okay, stupid example, but it's a good one because, right, so force being equal, meaning the force of the putt being equal, all right, if the mass is small, like the golf ball, it will cause the ball to accelerate at a huge rate, all right? If the mass is larger, remember that law of inertia, right? This truck is going to resist that motion more than the golf ball because it has more mass. Therefore, the acceleration will be smaller, okay? So we will not do this portion of the lesson, so you can ignore that, cross it out in your workbook. You remember the steps to problem solving? We're doing them all except for our diagrams. So let's get started here. So determine the magnitude of the force acting on a 10 kilogram mass accelerating at 4 meters per second squared. Our givens are that they want us to calculate force, so question mark for force. 10 kilograms is your mass, 4 meters per second squared is your acceleration. Given that F equals ma, substitute our values of 10 kgs and 4 meters per second squared, and we will obtain the magnitude of the force is 40 newtons. All right, 40, two significant digits based on 4.0, 1, 2. This has 3, so we take two significant digits. Our next question is as followed. We have a 200 kilogram mass. It's our mass. Accelerates when a net force of 800 newtons x on it. Calculate the acceleration. Wants us to calculate acceleration, so our formula will be an A equals formula. The force is 800 newtons. The mass is 200 kilograms. F equals ma. Rearranged to solve for A is A equals F over m. So we divide m on both sides of the equation to get this equation as follows. And substitution, notice that because it gives us direction, we have that in our substitution, and our answer, because forces are vectors, we include those vectors if they're there, okay? And 800 divided by 200 is 4, and we should have actually 3 significant digits, so this answer is 1 sig dig off to 4.00 meters per second squared to the north. The next questions in your workbook are advanced questions. You will not be getting questions such as these in Science 10 physics, but you could do them if you want a challenge. And I've posted the answers for you if you want them. So there they are. And the next lesson will be on mass and weight. So thank you for your attention, and we'll see you in the next lesson.